Hello students, in this module we will discuss about the heating effect of electric current. It is a matter of common experience that on passing electric current through a filament of an electric bulb, it gets heated and glows brightly. Similarly, on passing current through an electric heater, the coil of the heater becomes red hot. Do you know why? It is because in an electric circuit, electrical energy is converted into heat energy. This effect is known as thermal effect of electric current or Joule's heating. Here we will see how much amount of heat is produced when I current flow through the resistance R. Here this resistance R is connected across the voltmeter V. You know that current I is flowing through the conductor means Q charge is flowing in a time interval T. So when Q charge flows through the conductor in a time interval T, that means the current I is equal to Q by T, that is Q is equal to IT. Then the work done to move the charge Q across the resistance R, that is W is equal to V into Q. Then V is equal to IR, Q is equal to IT, that is W is equal to IR into IT, that is I square RT. This is the work done to move a charge through the resistance R. So work done is converted into heat energy. So we can say that heat energy H is equal to I square RT. This is Joule's law of heating. According to Joule's law of heating, the heat produced is directly proportional to the square of current for a given resistance, directly proportional to resistance of a given current, and directly proportional to time for which the current flows through the resistor. That only we have written here, H is equal to I square RT. Next, we are going to discuss electric power. You know what is meant by power. Power is the rate of doing work, that is P is equal to W by T, that is equal to H by T. Then how can you define electric power? Electric power is the power consumed by a device that carries 1 ampere of current when operated at a potential difference of 1 volt. That is, work done is equal to 1 volt into 1 ampere, that is 1 joule, that is equal to 1 volt ampere. Then the unit of power is watt. So you know that power is equal to joule per second, that is equal to 1 watt. Then higher unit of power is kilowatt. 1 kilowatt is equal to 1000 volts. Electrical energy is the product of power and time. So we can say that the unit of electric power is watt hour. So what is watt hour? Watt hour means 1 watt hour is the energy consumed when 1 watt of power is used for 1 hour. The commercial unit of electrical energy is 1 kilowatt hour. So what is 1 kilowatt hour? 1 kilowatt means 10 to the power 3 watt. 1 hour means 60 minutes into 60 seconds, that is 3600 seconds. So 1 kilowatt hour means 1000 into 3600, that is 3.6 into 10 to the power 6 watt. See, kilowatt hour is another name is unit. You know that in your home electric bill it is coming in units. So we can say that 1 unit is 1 kilowatt hour. Here we have few questions related to the heating effect of electric current. Why is tungsten used almost exclusively for filament of electric lamps? You know that the resistance of tungsten is very high. The heat produced is directly proportional to resistance. When electric current is passing through the tungsten, the heat produced become high and the melting point of tungsten element it is very high 3300 degrees Celsius. So the on passing electricity through tungsten filament, its temperature reaches to 2700 degrees Celsius and gives heat and light energy without being melted. The next question, why are copper and aluminium wires usually employed for electrical transmission? You know that the resistance of copper and aluminium is very low. Here also the heat is directly proportional to the resistance. As the resistance is very low, the heat produced is very less. So the energy loss in the form of heat energy is very less when we use copper or aluminium wire. Now we will see what is fuse. What is the function of fuse? Fuse is connected in series to the household circuit. Fuse is made up of alloy of tin and lead. It is having low melting point and high resistivity. When the current in the circuit increases, then the fuse wire melts and protects the household appliances. Here, this is a fuse. It is enclosed in a glass housing. The amperage, the rating of this fuse, it is 13 ampere. That means it allows only 13 ampere to flow through it. If the current exceeds 13 ampere, it melts and protects these appliances. A fuse consists of a metal strip or wire fuse element of small cross section compared to the circuit conductors mounted between a pair of electrical terminals and enclosed by a non-combustible housing. The fuse is arranged in series to carry all the current passing through the protected circuit. The resistance of the element generates heat due to the current flow. The size and construction of the element is determined so that the heat produced for normal current does not cause the element to attain a high temperature. If too high current flows, the element rises to a higher temperature and either directly melt or else melts a soldered joint within the fuse, opening the circuit. The fuse element is made up of zinc, copper, silver, aluminium or alloy of tin and lead to provide stable and predictable characteristics. The fuse ideally would carry the rated current indefinitely and melt quickly on a small axis.